So chapter 4 activity. A life insurance company sells, excuse me guys, one sec. So let's begin with question 1. A life insurance company sells 250,000 one-year term life insurance policy to 20-year-old male for $350. According to the National Vital Statistics report, the probability that the male survives the year is 0.998734. So there is a very, very high chance that the male will not die and will not get the money. Compute the expected value. So we're going to do the expected value. Remember the expected value, guys, we gave you a formula yesterday. It's this. It's the mean. But in order to find the mean, I need to draw the probability distribution, XPX. Here we have two values of X. You pay the premium, which is $350. And if the person doesn't survive, he will get, just the $250,000. So when you subscribe, to this 1-year term life insurance, you have to pay $350, guys. And once you pay the money, it's not the money that you have anymore. It's a money that you lost. So it's a negative money. So that will be negative $350. And the probability that you would lose this money is very, very high. And actually, it's a good thing because nobody buys a term life and hope that they're going to die tomorrow after tomorrow. So the probability is 0.998734. Now, the worst scenario, guys, the person dies and his family, just gets the 250,000. Well, actually, if the person doesn't make it, just with through the year, his family will get the 250, but actually your gain will not be 250,000 because you already paid $350. So your gain, guys, will be 249,650. And if you ask me how did I get this money, I just subtracted 350 from 250,000. That's the money that the family, the one who inherit, just the money, will get that 249,650. What would be the probability that the person will not survive? If we know that the person will survive is 0.998734, what would be the probability that the person does not survive?
You just subtract 1 from that, right?
Got it. You got it. Exactly. That is 100% correct. 1 minus. And you guys, if you buy this kind of insurance, you would hope that this probability is very low because we want to survive it and not use the insurance. All right. And now to find the expected value is easy. You take this X value and multiply by the probability. You take this X value, multiply by the probability, and then you add them up. So it will be.
What are we multiplying again? 350 by the 99.8734
plus the 249,650 by the 0.001266. Yes. And that, if you do the math, guys, you will get negative 33.50. That would be the expected value. A student told me, yes, go ahead.
In what situation do you use to get the mean X times probability of X? And what situation do you use N times P?
Oh, that's a good question. If you have a probability distribution in a table, you use XPX. if you only have the probability of the success and you have the number, just of successes n, you just use NP. So if he gives you a binomial situation, use NP. If he doesn't give you a binomial situation, he gives you something like that, you just use sum of x, px.
Will the questions tell us like whether to compute the expected value or?
But you know what? If he gives you NP, he would not ask you to do the expected value. He'll ask you for the mean. Once you see a probability of success at the very beginning of the problem, just like this, you see this one here, then it's NP. Actually, the two answers are exactly the same, but NP is a lot easier than having to do this one. So if you don't have a table, guys, just use N
But
times
this
P.
question didn't give us an n. It didn't say how
Oh.
many people, right?
Oh yeah, definitely.
So that's why we used x
Yeah,
times p of x.
Yeah, definitely. That's a good question. Number 2, according to American Lung Association, 77%, so that's a P, guys, of adult smokers started smoking before the age of 21. 10 smokers are selected at random. You see, that's N. And the number of smokers who started smoking before 21 is recorded. The number of smokers out of this 10 could be a 0 or a 1 or 2 or 3 or 4 or 5 or 6 all the way to 10. Explain why this is a binomial experiment. If he gives you the probability of success and he gives you a fixed number of trials, guys, it is a binomial experiment. Fixed number of trials, which is 10. Now, probably you wonder, is a person a trial? Yeah, you're surveying 10 people, so it's a trial, and with each one, so you have 10 trials. And then probability of success is given. It doesn't change from one person to another. These are the conditions of the binomial experiment. Use your TI-84 to find the probability that exactly 8 of them started smoking. Remember, guys, we did that yesterday before you left. And probability of exactly A, I'm going to stick to it. It means probability of exactly X equals what here? 8. And I'm going to put binomial PDF. I'm going to put N, I'm going to put P, and I'm going to put 8 here. N is 10, guys. P is 0.77. Those two values will not change from one question to another. They're going to be always the same. And then here, 8. Okay. Let's do that. If you guys can do it with me, so just you practice the use of the calculator, just make sure. It's a letter A. So number of trials is 10, 177. X value is 8. And 294142. All right, next question. What's the probability that at most 8 of them started smoking before 21 years? So you survey 10. What's the probability that at most, no more than 8, say that they started smoking before they became 21 years old? So at most, guys, means less than or equal to. And if you have this handout handy, you know how to deal with at most. It's a CDF. NPA. So it will be binom CDF, N, which is 10, P, which is 0.77, and put 8. I don't want you to think these are the same, guys. Look, this says PDF and this says CDF. CDF means it will do a PDF on all of them. PDF on 8, on 7, on 6, on 5, on 4, on 3, on 2, on 1, and 0, and add them up. But you don't have to do any of the work. It will be done in the background for you. CD, oops, sorry, I picked the wrong function. Here we go, it's B. So 10 0.77. X value is 8. And you get 7079. D. Use your TI-84 to find the probability that at least 5 of them started smoking. At least, guys, means this. So there will be probability of X greater than or equal to 5. So we need 6, 7, 8, 9, 10. That's what we need. It will be 1 minus binomial CDF. You do 1 minus the ones that you don't need. You put 10 here, you put 0.77. And what are the numbers that you don't need, guys? We need 6, 7, 8, 9, 10. So what are the numbers that we don't need? The 5, the 4, the 3, the 2, the 1, the 0. So that will be binomial CDF at 5. And look, guys, for at least A, look what I said you do. You do 1 minus binomial CDF NP A minus 1. Watch here, guys. We're doing oh, greater than or equal to 5. I'm sorry, I made a mistake here. It should include 5 because 5 is included. So this one will be a 4 here. Because at least 5 is okay. So 5 or 6 or 7 or 8 or 9, 10, the ones that we don't need, 4, 3, 2, 1, 0. So that should be a 4 here. And that goes in line with the formula that I gave you. If it is at least A, you just do 1 minus binomial CDF and you put A minus 1, 5 minus 1, which is 4. And how do you do this? You can do the binomial CDF first and then subtract the answer from 1. Second distribute. So I'm just going to change this to 4, guys. And it will be 1 minus 0.0130. Which is 987. E, use your TI-84 to find the probability that more than 5. More than 5 is this sign, guys. That's more than. You write it like this: P capital, open parentheses, X more than 5 equals. And it will be 1 minus more than 5, guys, means 6 or 7 or 8 or 9 or 10. That's what we want. So it will be 1 minus the ones that we don't want. So it will be what, guys? 10, 177. What would be the number here?
Isn't it any of the numbers that are more than 5?
Yes.
So 6, 7, 8.
So that these are the ones that we want. We want 6, 7, 8, 9, 10. So the ones that we don't want is 5 and below. So you just put a 5 here. And that's the rule, guys. You can always use this. X more than A, more than 5. 1 minus binomial CDF and P5. So just put 5 again. And that would be, guys, 1 minus
Can we go back to after this question D?
yes, let me just finish this.
And are we gonna do the Socratic activity before or after the lesson today?
Just once I finish this today. It will be a very short activity. Let me see. So second, distribute. CDF. Okay, so we're gonna do 10.77 and then 5, guys. So it's 1 minus 0.0569. And then you just subtract and get the answer. What's your question about D?
So I understood how you got x is greater than or equal to 5 and how we're using 4.
Yes.
But when you're typing it in the calculator, I just got lost at where.
Okay, let me show you. So that's what I did on the calculator. I did second and distribute. I did the CDF first, and I put the 4 here. And whatever the answer I have, I did 1 minus that answer.
So 1
So
minus
0.0130.
and that gives point. Oh, okay. So you have
Got
to
it?
you have to type in the binomial CDF and then.
Oh, yeah, of
Okay.
course. Use your calculator to find the probability that less than 5. This is how you write less than 5, guys. Okay, can you tell me what's less than 5? It's what? 4 or 3 or 2 or 1 or 0. So you guys, when it is less than 5, it's the same thing as binomial CDF, but not with 5, with 4. Because the CDF, it has to be at most. So probability of X less than 5, guys, means probability of X at most 4. And you can use binomial CDF on 4. And you can use this to guide you guys. Look, less than A, less than 5. Your A is 5 here. You do binomial CDF, N, P, 5 minus 1, which is 4. And which is actually will be second distribute. Oh, I just did it right there. It was there on the screen. (0.0130). Find the mean and the standard deviation of the, you see, it says mean and standard deviation of the binomial distribution. Once he says binomial, guys, use the basic formula, MP, which is 10 times 0.77, which is 7.7. And the standard deviation, there is a formula. N is 10, P is 0.77, and Q, guys, is 1 minus P. And if you do the math, you will get 1.33. So this is pretty much, oh, I'm sorry. This is pretty much it for chapter 4. What I'm gonna do now, I'm gonna just go to the assignment and show you that it's no different from what I did. The first question state whether the variable is discrete or continuous. Remember, discrete, you count them 1, 2, 3, no decimals, no fractions, whole numbers. Continuous can be any value, could be decimal. So the height of a player, you have to decide whether it is continuous or discrete. Temperature, anything that can be measured using a tool is not discrete, is continuous. So that's a hint for number 2. For number 3, he says the random variable X represent the number of cars per household in a town of 1,000 households. What's the probability of selecting a household that has less than 2 cars? What does less than 2 cars mean, guys? How many cars?
0.
1 or 0.
Okay, you said it, 1 or 0. Or means addition. So what you do, you figure out the total number of households who have 1 or 0 cars and divide it by the grand total, which is 1,000. That should be an easy one. Number 4, he's asking you check if this is a probability distribution or not. To check if something is a probability distribution, you have to make sure that each probability is between 0 and 1, and the sum of probabilities is 1. Well, actually, guys, if the first one fails, you don't need to check the other one. Once enough, it is enough for one condition to fail for the whole thing to fail. Look at it. If you see any of the probabilities not between 0 and 1, then you say that it's not a probability distribution.
Wait, okay, so it doesn't have to be that the outcomes add up to 1. It has to be that
No.
they.
Both
So
of them. If the first one, I mean, here you can see there is a problem with the first one. But if the first one works, then you add them up, and then if you see if you get 1 or no. But if this one fails, then you don't need to check the second one, because one condition is fails. That's it. The whole thing fails.
Okay, and the first condition, just so I'm making sure right now, is that it's less than or equal to 1, correct?
Yes. And
For the-
positive. It has to be positive.
Okay, got it.
You can see the issue now. Probabilities can never be negative, guys. Just remember that. Number 5. How do you find the mean and the standard deviation of a probability distribution? He gives you the X values, the probability. You see here, you can't use NP because he didn't give you a probability of success. So that's why we couldn't use, just NP. Then you have to use that formula. But I'm going to save you time. We already learned how to do this on the calculator. So let me just demonstrate one more time how to use the calculator for this one. Watch, guys. First of all, you put the X value in L1 and the Y values in L2. So I'm going to turn the calculator on. I already have an exercise, an example from yesterday. So you go to stat edit. Let's assume, guys, that X values are here and your PX values are there. You go to stat, you go to calc, you go to one variable statistics. You make sure that this is L1 and you make sure that the second one is L2. Let's say, guys, you have nothing here. So look what you do. You pick the second key and then you put number 2. And then you hit calculate. The first value that you get is the mean. This is the mean, it's mu. Don't look at the rest of the values, and then you look at this one, guys. Sigma is the standard deviation. Mean. Of course, these are not the answers because I didn't use the same data sets, but you just do it exactly the same. And finally, guys, this exercise, which is very similar to the one that I did in the activity. So let me just walk you through this. A recent survey found that 72% of all adults, so that's a P is 72%. Of all adults over 50 wear glasses for driving in a random sample of 9. So N is 9. I'm in mute here. What is the probability that exactly 6 of them you wear glasses? You need to find probability of X equals 6. And guys, this is binomial PDF. B, what is the probability that at most, guys, at most refers to binomial CDF. You just use CDF here. C, what is the probability that at least 6 of them, at least means this, greater than or equal to, and you guys, we just did one example and you can always refer to this, at least. What do? At least 6, you have 6 here, then it will be 1 minus binomial CDF MP, 6 minus 1, which is what? 5. What is the probability that none of them? Well, I worked that with the other group and we agreed that none of them means X equal what, guys? 0. And that will take you again to what? Binomial PDF or CDF? What would that be here?
PDF.
PDF. I mean, be honest with you guys, you can do all the questions with PDF if you just use PDF as many times as you need to and then add them up.
So with that, that answer for that question, do you want us to how it would?
Here's how I like it. Exactly. That's a good thing. Here's what I like it to do, guys. I like it to put this here. Then I would like you to put binom PDF. Just follow exactly the way I solved the problem. Put the N, P, and then 0, and then give me the answer here. Just 3 steps. And round your answers to 4 decimal places.
Are you talking for our chapter assignment? You want to
Yes.
see this?
Yes.
But the questions aren't exactly the same, are they? So I was
No,
looking
that
at-
is, yeah, it's just, this number 6 is very much, guys, just like this activity that we just did. What is the mean of the binomial distribution, guys? It's NP. You have N and you have P, just find it. What is the standard deviation? It's the square root of MPQ. And guys, those questions are from my math lab, very much just like what you were going to be doing in the homework. Very much, this is a summary of the chapter. I try to include everything, just in this assignment. Except I didn't ask you to find the expected value, but remember, guys, the mean is the expected value. This is the same thing as the expected value. It's the same thing. Okay. Now, some of you might like to use StatCrunch to solve binomial probability. So I'm going to take you to StatCrunch right now. And
Professor,
yes.
I have a question from earlier when you showed us how to put L2 in the calculator. What was that for?
Just to find the mean and the standard deviation of the binomial probability distribution. You put the X values in L1 and the probabilities in L2.
Okay, thank you.
You got it? And then when you do this, when you go to stat, calc, one variable statistics, make sure that your X values are L1 and your probabilities is the frequency list. You just put L2 and then hit calculate.
Okay, thank you.
Yeah. Now, guys, let me show you how you could use. Look, guys, how you get, how to use StatCrunch for this chapter. You just go to stat, calculators. And can you guess which calculator I'm going to pick up, guys? What's the title of this chapter?
Binomial.
Yeah.
Binomial.
Okay. And the activity we did, guys, he gave us the P 77%. Watch. I'm going to change this to 77%. And N, I think it was 10. Yeah, it was 10. And let me show you how you can answer all those questions using this calculator. Let me move this up. Okay. He says, what was the probability that X is exactly 8? Look, guys, what you do. You just put equal here. And then you put 8. Remember, the answer was 0.2942. Watch. Enter. And here you go. 2942. Then the next question was, what's the probability that at most 8 of them? You need to know what at most means, which is less than or equal to. So look, guys. Choose the sign. There is no 1 minus in using the calculator. Just do it directly. And did you notice at most 8? Look what the calculator highlighted. It highlighted the probability of X equals 8 and 7 and red and 6 and 5 and 4 and 3 and 2 and 1 and 0 all the way to the end. And remember, the answer was 0.7079. This is the answer. Then we said, what's the probability of at least 5? Look, guys, just change that to 5. And you need to change this one to at least. And look, at least 5 means 5, 6, 7, 8, 9. So what the binomial calculator does, it will find the probability of each one and add them up. And look, that's the answer.
Can we use this on the exam?
Yes. Yes, you can. And actually it's a privilege. It will not happen probably in the upcoming semesters because we will be doing exams in class. But Since we're doing it online, I don't mind whether you use the i84 or you use this calculator. Just become proficient in it. You have to know how to use it. So you notice, guys, there is no need for me to do 1 minus. This calculator does it all for me. It just does the answer directly. Then more than 5, we did the part E was more than 5. More than 5 will be this. And look, the calculator is going to highlight 6 and up. And that's the answer. And then the last thing we did, less than 5. And you guys know what's going to be highlighted when we do less than 5. It's going to do 4, 3, 2, 1, and 0. Watch. That's the less than. Compute, look. And then you get the answer. And not only that, let's say he asks you to find the probability of X between 4 and 7. Watch, guys, if you do between, let's say 4 and 7. It does even more, better, more, just than what you ask for. And look, between more 4 and 7, it does 4, 5, 6, 7. Watch, 4, 5, 6, and 7. And that's how you use. But this calculator doesn't do the mean and the standard deviation because they're very easy to compute. So there is no feature for that, but you can see how easy it is to use this binomial calculator. So feel free to use it if you like to. And again, to access the binomial calculator, guys, you just go to Stat, Calculators, and then Binomial. Okay.